let's create the cam toolpath for our first part. So I'm going to switch from model to cam. And the first thing we want to do is start with a setup. And as a general rule, the idea here is you'll work left to right. So setup, and then we'll create some toolpaths, and then we may simulate them, and then finally post them over here. So setup, remember the blue is the sky, so that's good, but I don't like the default stock setting. The second tab here is stock. Relative size box just adds some material. Let's go with a fixed size box. So in this drop down menu, fixed size box. If you guys remember from class, our part was, raw material was 3 inches in the Y, and the 4 inches was a little bit long, so we'll just say 4.1. I would rather be more conservative here by adding more material, say even 4.2. That way my first cut is, if anything, a little bit light rather than too heavy. Height of 1 inch is fine. I don't like this round up to nearest 0.5, and in fact I'm going to not only change that to 0, but I'm going to right click and say make all default. That means the rest of the time I use Fusion 360 in any file or part, it's going to change that default to 0. Notice that changed my height to 0.75, so I actually want it to be a 1 inch part. So that's the correct size of our block. Now if we go back to the first tab, which is called Setup here, we need to do a few things. First thing, which is one of the most common mistakes that folks forget to do, is we need to tell it what the model is. So I'm going to click this nothing right here and click our part. The reason that exists is that when you work with Fusion 360 files that have multiple components in them, you need to tell it which one you're actually working on machining right now. The next thing that we want to do is we want to set where the stock is located, so that we're just leaving about 10 thousandths to clean off with our face mill. So I'm going to change the origin to, actually we can leave that the same. I'm going to change the stock model position in the Z. So if you see here, our height is 1 inch, that's okay, but the model position, instead of it being centered, I'm going to say offset from top 0.01. And if we zoom in now, we can see we're going to set Z0 on the top of our raw material, but it's actually going to take that face mill and cut off just about 10 thou, which will clean up the top of our part. Now I'm okay. Click OK. And using the cube in the top right of the screen here, I can click on the top option. I can look down at my part and I can see it passes the smell test. If we remember from our print only calls a 2.25 inch wide part, and we actually know the stock is 3 inches, so we see some of that extra material, which is perfect. First thing to do, 2D face. We'll select tool 47, click OK, and you can just click OK. We should get a toolpath. The only thing we wanted to do was just to make sure that the face mill gets clears the whole part, all the material. I'm going to right click, edit, and under geometry, which is the second tab, passes, the fourth tab, if we hover over this fourth option down called stock offset, you'll see the description that comes up, which is actually very helpful. It reads, specifies the distance the machining boundary extends beyond the stock, both X and Y. So it's basically adding some stock to make sure the face mill clears everything off. So before I do that, take a look. Right now, our toolpath basically, comes in below the part, but it goes past the part, just a little bit past the center line. If we add some stock to it, it should move that blue line further out. So let's try that now. I'll add a 1/4 inch of stock offset. And sure enough, we see that blue line is further out, which means that tool is going to cut more on the back side of the part, and the front side is covering the front as well. Looks good to me. We need to rough the part out, so we'll use 2D adaptive clearing. Pick our shear hog, which was tool 49. Under geometry, we need to pick the two wings that we want to be milling out. So 1, 2. And if we click OK, we'll get a toolpath, but there's one big mistake here. Okay, actually my Fusion has some different settings which change the bottom height. Yours will probably have automatically selected the correct bottom height, so you can ignore that error there. This should be what yours looks like. Here's the big problem with that. We do a simulation right now, and we have material on. We take a look. The first pass, way too much material. Way too much. And in fact, it even left some out there. And the second pass was much smaller, which is usually a sign. Why are those passes the different thickness? With adaptive roughing, they should be pretty constant. And the reason is that we haven't told it to use the additional stock. So I'm going to right-click on the 2D adaptive, edit, and under geometry, I'm going to check stock contours. I don't even think we need to pick it. I just think we need to enable it. Let's see what that looks like. Perfect. And sure enough, if you compare it, we've got much wider toolpaths, which means it's going to correctly account for the stock of basically the raw material we're starting with. We've got to edit our feeds and speeds a little bit. It depends on which machine we were on, the 1100 or the 440, but I'll just say 1/4 inch width of cut, which is the optimal load. Again, if you hover over it, you'll see a description that says it further explains that, and we'll do multiple depths with no more than, say, a 0.2 depth of cut, and we should now get a toolpath that's much better for our shear hog, which is perfect right here. Last thing I'll do is I'm going to create a 2D contour. So 2D contour. I'll pick tool 31. I will pick my contour right there. And again, I've got to pick the bottom height. You probably don't on your computer. Click OK, and let's see what we get. That looks good. Again, I like to have what's called a finishing overlap, where it will start and stop by going past, or so it'll stop after it's gone past the start point. We usually edited that in the classes that you attended, but if you need to tweak that or check that, it's in the 4th tab called Passes, Finishing Overlap. 0.05 is plenty good. As an FYI, I don't think I mentioned this in the classes, you can control the entry position. So if we say click here and we just pick a point along the part, take a look, it'll move the entry and exit to that point right there. Now, because we are going to be machining this part in the second session of the class, and we're going to reset it up on the mill, we might as well leave ourselves some cushion. So let's go back on the 2D contour and do stock to leave of radial of, say, 10 thou. That way, when we set our part up again in the afternoon session, we've got a little bit of meat to take off around this, and that means if we don't set it up perfectly with the edge finder, we should be okay, because again, we have got a little bit of fudge room. That's the cam for the first part. If we go to setup, again, you want to click on the top setup here to simulate through everything. Click simulate and click play. We see it faces the part off. Comes in with a shear hog. And lastly, it came in quite quickly on the simulation with the tool 31 to clean up that island.